Okay, picture this. You look up, and instead of a skyscraper going up, there's one hanging down.
Right. From an asteroid in orbit.
Exactly. I know it sounds totally science fiction, but it's this incredible, really audacious concept we're diving into today. And you brought us some absolutely fascinating sources about it, this thing called the Analemma Tower.
Yeah.
So our mission, basically, is to unpack these sources you shared. We want to really get our heads around this wild idea from Cloud's architecture office, explore all the features they're dreaming up, and then, critically look at the science, the engineering. Where does it, hit a wall? What are the real roadblocks?
Right, and we've got a good mix of sources here. Architectural pieces from back in 2017 when it first dropped, news coverage, some more recent sort of scientific takes. They paint the big picture, but also bring in that reality check. Is it even remotely feasible?
Okay, let's get into this concept that you found so interesting. So the core idea is just flipping the script on skyscrapers, right?
Yeah.
Instead of foundations in the ground.
It hangs from space. Suspended.
Yeah. And the firm is Cloud's architecture office. Very evocative name.
And the tech they imagine making this possible, they call it the Universal Orbital Support System, UOSS.
Okay.
The idea is you grab an asteroid, put it in just the right orbit, a geosynchronous one, and then you tether the tower to it with super strong cables. It's literally a foundation in space.
It's a mind-bending shift in perspective. And the scale, the sources say this tower hangs down more than 32,000 meters.
Over 104,000 feet, yeah. It's staggering.
Just trying to picture that distance.
And get this, one article mentioned the cable attachment point on the tower could be 35,750 kilometers up.
Wow.
With the asteroid itself maybe 50,000 kilometers out. So yeah. We're talking deep space, not just, high altitude.
So what's it like inside this thing? The sources describe this layered structure, 9 sections.
9 distinct zones. Apparently, the top sections, closer to the asteroid, are for things like funerary services, reliquaries, worship areas.
Huh. Closer to the heavens, literally.
Maybe that's the idea. Then moving down, you get residential, then business, commercial.
And right at the bottom, basically scraping the sky, is entertainment, shopping, dining.
Yeah, the lowest point. But the really cool part, where it gets its name, is the movement.
Right, the Analemma part.
Exactly. It's in a geosynchronous orbit, so it takes 24 hours to go around, matching Earth's spin.
Yeah.
But crucially, it's not orbiting right over the equator. So its path traces a figure-8 pattern in the sky each day.
Okay. That's the Analemma. I see.
That's the Analemma.
So for residents, it's a 24-hour cycle with these constantly shifting views, different parts of Earth rolling beneath them.
Totally. Different heights, different landscapes, cities, oceans. And one source noted the slowest speeds relative to the ground are at the very top and bottom of that figure-8 loop.
Makes sense. And how does it sustain itself way up there?
Well, power is supposed to come from space-based solar panels above the thick atmosphere, so they get constant, strong sunlight. And water. They talk about a semi-closed loop system. It would filter and recycle, but also collect condensation from clouds it passes through and rainwater.
And moving between floors or sections, I guess.
Cableless electromagnetic elevators. You'd need something fast and efficient for those kinds of distances.
Definitely. But living at 32,000 meters, that's not exactly shirt sleeve weather.
No kidding. The sources are clear about the extreme conditions. Upside? Maybe 45 extra minutes of daylight because you're seeing over the curve of the Earth.
Architect's bonus.
Downside, temperatures around minus 40 Celsius and near vacuum pressure.
Oh.
Yeah, stepping outside. You'd need a full-on spacesuit, basically.
Okay, so the concept art often shows it over New York City.
Right.
Which makes sense. The architects are based there.
Right. But the sources say the plan, if this were ever built, was actually to construct it in Dubai.
Dubai. Why there?
Well, a couple of reasons. One, they have proven expertise in building super tall structures. Think Burj Khalifa. And, critically, cost. The sources estimate construction costs could be 5 times lower in Dubai than in New York.
5 times, okay. That's significant.
Huge. So the idea was build this massive tower on the ground in Dubai, then somehow lift it into orbit and tow it to its final spot.
Tow it. An entire skyscraper.
Well, orbitally transfer it, maybe over New York, maybe somewhere else. Because it's suspended, you could theoretically park it above any city by adjusting the asteroid's orbit.
Okay, this is where my brain starts to hurt a little.
Right. This is the transition point from the, amazing renderings to the hang on a second part. The sources call it a utopian thought experiment, a speculative project. It's not meant to be buildable now.
Gotcha.
So let's look at the feasibility hurdles they identified, starting with what they call the minor problems, which seem pretty major to me, but okay.
Okay, minor problem number 1, getting the asteroid in the first place, landing on it, moving it. Is that even possible?
The sources are somewhat optimistic here. They say asteroid capture and manipulation is becoming more feasible. They point to things like the Rosetta mission landing on a comet as like proof of concept for the tech. And the argument is, if the real estate in this tower is so valuable, think astronomical price per square foot, maybe it justifies the insane cost of wrangling an asteroid.
Interesting justification. Okay, next minor problem. Building the tower itself on the ground first.
Right. If you build it in Dubai, it'd have to be unbelievably tall, even before lifting. One source suggested maybe 27 kilometers tall.
Just on the ground. Why so tall?
Because the base needs to clear ground obstacles once it's in orbit. Remember that minimum height thing we'll get to? They call building this 27-kilometer structure a minor problem for now. They admit current materials aren't strong enough, wind loads would be insane, but they assume future tech will solve it.
Okay, assuming future tech, what about the cable? Tethering it. We're talking over 35,000 kilometers long.
Yeah, another minor problem with current technology. They throw around terms like carbon nanotubes.
Right, I've heard of those. Super strong.
Supposedly. But the cable needed for this would have to be at least 6 times stronger than even the theoretical strength of CNTs we have now.
6 times? That's not minor.
Not minor at all. Again, it requires breakthroughs in material science that just don't exist yet.
All right, what else is minor? Lifting it? Attaching it?
Oh, yeah. That's described as tricky. Another minor problem. Apparently, see, a tower built for compression on Earth behaves totally differently under tension when hanging. The materials, the structure needs to handle both. Plus, the asteroid isn't just sitting still over Dubai. It's moving in that figure 8. So the window to actually connect the cable, tiny, seconds maybe, requires absurd precision.
Okay.
And then there's the physics of attaching it. You hang this unbelievably heavy tower below the asteroid. That lowers the whole system's center of mass. Which means if you don't counteract it fast, the whole thing starts to fall towards Earth. It puts it on a collision course.
Oh, great.
So the plan involves needing incredibly powerful thrusters to lift the tower immediately after attachment, and needing potentially thousands of kilometers of slack in the cable just to buy enough time for the thrusters to work before it hits the atmosphere.
Wow. Okay. If those are the minor problems, capturing asteroids, inventing new materials, precision orbital mechanics under immense time pressure. What are the major problems?
This is where it really unravels, according to the sources. The number one major problem is orbital stability.
Stability?
Yeah. The physics is pretty clear. Anything orbiting Earth that has a significant part dragging through the atmosphere, even the really thin upper atmosphere, it just can't stay up. There's air resistance, drag.
Way up there.
Even way up there. It constantly slows the asteroid down. And if it slows down, its orbit decays. The whole thing spirals inwards and eventually falls.
So it wouldn't just stay in that nice figure 8 path.
Not without constant correction. You'd need continuous, massive thrust, burning unbelievable amounts of fuel just to fight the drag. One source compared it to trying to fly a skyscraper vertically at airliner speeds using wings. It's just fundamentally inefficient and unsustainable in orbit.
Okay, that sounds pretty definitive. A major problem indeed. What else?
The orbit itself. That diagram showing it looping conveniently over New York and then down near Peru.
Yeah.
The sources say that specific path isn't actually possible. Orbital mechanics dictate that the northernmost latitude an orbit reaches must be mirrored by an equal southernmost latitude. Meaning if it goes as far north as New York, it has to go just as far south. Much further south than Peru. More like southern Chile or Argentina level.
Ah. So the idea of easily hitting multiple specific cities in a neat loop? Not really feasible.
Nope. They call this orbit diagram a minor problem in one source, but it's rooted in fundamental physics.
Got it. And this ties into minimum height.
Exactly. Another major problem. The bottom tip of the tower has to stay clear of the highest terrain along its entire ground track. So on that hypothetical New York-South America path, the highest points are the Andes Mountains in Peru or Chile.
Right. Tall mountains.
Very tall. Which means the lowest the tower could possibly get is about 5,000 meters or over 16,000 feet above sea level.
Wait, 5,000 meters minimum. So those cool pictures of it hovering like right above the Empire State Building?
Pure fantasy. Completely misleading.
Yeah. 16,000 feet that's high altitude. Not exactly reach out and touch the city.
Not at all. It really dampens that visual appeal. And if you did try to dip lower over a city temporarily, physics dictates its speed over the ground would increase massively during that dip.
Okay, practicality check. How do people get on and off this thing? I saw concept art with base jumping.
Heh, yeah. Base jumping sounds cool, but probably suicidal. Remember, the tower is moving relative to the ground at an average of like 720 kilometers per hour, maybe 450 miles per hour.
Right, bad idea.
Very bad. Except maybe at the very top and bottom points of the figure eight, where the ground speed momentarily hits zero. But the more detailed plan involves a ground-based transfer tower.
Okay, a tower on the ground that connects.
Yeah, but think about the timing. The orbiting tower flies overhead. The connection window might only be a few seconds each day. The precision needed is, well, astronomical.
And didn't you just say the minimum height of the orbiting tower is 5,000 meters?
Bingo. Which leads to the potential absurdity pointed out in one source. This ground-based transfer tower might need to be 5,000 meters tall itself just to reach the Analemma Tower during that brief flyover window.
So you have to build a 5-kilometer tall tower on the ground anyway.
Pretty much.
Right.
Which kind of negates the whole cost-saving benefit of building the main tower cheaper in Dubai, doesn't it?
Yeah, it really starts to sound completely unworkable when you line up all these problems.
Exactly. So given all this, the stability issues, the impossible orbit, the height constraints, the transfer nightmare, why even propose it?
That's the question.
And the sources are pretty consistent. It's not a serious construction proposal for today. It's labeled a speculative project, a utopian thought experiment.
So it's about pushing boundaries, not laying bricks.
Precisely. It's meant to make architects, engineers, maybe all of us, think outside the box. Challenge fundamental assumptions about buildings, gravity, location. One source even had a slightly cynical take. Maybe it's an ironic commentary on how insane real estate prices are in places like New York.
Huh. Like things are so expensive, maybe hanging a building from an asteroid is the only option left.
Sort of, yeah. It frames the absurd engineering as a response to absurd economics.
That's actually a really interesting perspective.
But even setting irony aside, the sources generally agree it serves a purpose. It raises real questions about the future: urbanization, space infrastructure, sustainability. Where architecture meets space science, meets city planning. It gives us this provocative glimpse, right? Even if this specific design is flawed, it forces us to imagine fundamentally different ways we might build or live, maybe off Earth someday. It sparks ideas that could lead somewhere actually viable down the road.
So there we have it. The Analemma Tower, an absolutely incredible visionary concept.
Mind-bending, yeah.
But one that runs headfirst into some pretty immovable laws of physics. At least for now, firmly science fiction.
But valuable science fiction, perhaps. Ideas that seem impossible can push us. They show us the edges of our current capabilities and maybe inspire the breakthroughs needed to expand them.
Yeah, absolutely. Well, thank you so much for bringing this one to us. It was definitely a wild ride unpacking it all.
No problem. It was fascinating to dive into.
So as you go about your day, maybe mull this over. What stands out to you from all this? Does imagining building down from the sky change how you think about cities or engineering or even just our little place here on Earth?